Hey, welcome back to your favorite trigonometry class. This unit, we're going to look at applications of trig functions. This chapter, I'm sorry, this specific unit here, we're going to look at right triangle trig and applications. There's our objectives there. Let's start out and remind you, I always refer to remembering sine, cosine, tangent with right triangle trig, right? This is right triangle trig here. Sine, cosine, tangent. I always remember, oh heck, another hour of algebra, right? Oh, opposite, heck, hypotenuse, another hour of algebra. That's how I remember it. A lot of people also remember SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent, right? So if you're looking at, if this is your angle theta right here, the opposite side would be right there. The hypotenuse is always opposite the 90-degree angle, right? The adjacent side is next to, adjacent meaning next to. And then, of course, we have our reciprocal functions here. So the cosecant, we'll just flip that over. Secant flips over the cosine. Cotangent, as you guys know, flips over the tangent there, okay? All right, let's find the value of each of the 6 trig functions of the angle theta here. Notice the side opposite there is already labeled. And typically speaking, with a right triangle, your hypotenuse is angle C, capital C. Your angles are capitals, right? So if I was to label this, this would be angle A, B, C. So angle B is the same as that theta right there. Okay. The side opposite the angle, so in this case, angle B, so I'm going to call this lowercase b. Side opposite angle A, I'm going to call lowercase a. So the side lengths are lowercase. So opposite capital C, which is the right angle 90 degrees, would be lowercase c, the 13 right there. Okay. Now, first of all, I'm going to say, well, I remember that a squared plus b squared equals c squared, right? The sum of the squares of the legs of a hypotenuse equals the square of the hypotenuse. Sum of the squares of the right triangle, sum of the squares of the legs of a right triangle equals the square of the hypotenuse. So the old Pythagorean theorem, the most important theorem in all mathematics. So a squared plus b squared equals c squared. So 5 squared plus b squared equals 13 squared. So we got 25 plus b squared equals 169. B squared, subtract 25, we get 144. Plus or minus 12 once we square root that. And we know this is a side length, so it's got to be 12. So b is 12. That's our first step. And then secondly, now we just say, oh, well, sine of theta, in this case b, right, that's our theta, is opposite over hypotenuse. So in this case, 12 over 13. Cosine, another our adjacent over hypotenuse. So 5, here's the adjacent side with respect to the theta. 5/13 tangent, opposite over adjacent, so 12 over 5. And then the reciprocals. Cosecant would flip that over 13/12. Secant flips that one over 13/5. Cotangent flips that over 5/12, and so on. Okay. All right, complementary angles. So if you're looking at angle A, its opposite side, lowercase a, its opposite side would be down there. So its adjacent side would be right next to it. And of course, this is always your hypotenuse, right? So if you're finding the sine of A opposite over hypotenuse, then you'd say you take that side, so the lowercase a over the hypotenuse c. So sine of capital A would be a over c. So when this is saying that the complementary, what are complementary angles? Well, if you look at look at the cosine, or I'm sorry, the A over C would be the same as the cosine of B, because the cosine is adjacent over hypotenuse. So now if we're doing the adjacent side to B, right, here's B, so the side that's adjacent would be right here, A, and the hypotenuse would be C. So the sine of A and the cosine of B, right, complementary, if you will, angles. So the complementary angle theorem just says the cofunctions of complementary angles are equal, right? So complementary angles meaning they add up to 90 degrees, so the sum is 90 degrees. So the cofunctions, if you remember the cofunction identities, right? Sine of 90 degrees minus x is cosine of x. Right, that's what these are saying. So if they're complementary angles, then the sine of the using those cofunctions would be equivalent, right? And you see those listed here. For example, sine of 79, 90 minus 79 is 11. Sine and cosine going together, if you will, right? Because that's the opposite over hypotenuse. Again, you could look at a right triangle if you wanted to on that, right? Tangent of pi 18ths. What's pi halves minus pi 18ths? Well, that's 4 pi 9ths. Tangent, cotangent going together on that. Cosine again was sine. What's the difference between pi halves and pi thirds? Pi sixths. Right? That's 60 degrees, that's 30 degrees, and so on. Alright, so we remember the old Pythagorean theorem. We also remember that angle A plus angle B plus angle C is 180 degrees, and of course if we have a right triangle, then we know that's 90 degrees. So the two left over have got to sum up to 90 degrees. Alright, use the figure if B is 4, lowercase b, so there's our lowercase opposite the capital B, right, the angle B. If angle A, so here's our angle A, 35 degrees, so lowercase a would be opposite that. This is our capital C, our 90 degrees, so lowercase c, the hypotenuse there. Alright, so B is 4, angle A is 35 degrees, find AC and B. Well, we don't have two of the three sides, so I'm not going to start with the Pythagorean theorem. But I can say, well, I know that the sum of the angles in a triangle 180 degrees, so why don't we start with that? We've got angle B plus angle A plus angle C, all add up to 180 degrees. We know that's 35 degrees, we know that's 90 degrees. So it looks like our angle B ends up being 55 degrees. Alright, number 2. So now we know this is 55 degrees. Now notice I have, with respect to A, I have the adjacent side, right? I have the adjacent side, so, and I have the angle, 35 degrees. So what I'm going to do is I'm going to say, why don't I use the tangent and and solve for A? I know tangent is opposite over adjacent. I know the tangent of A is opposite over adjacent. So the tangent of 35 degrees is opposite A over the adjacent side, which is the B, which is 4. Now I multiply both sides by 4. So times 4 times 4. So A is 4 times the tangent of 35 degrees. Okay, and then I punch that in. Make sure your calculator's in. Let's go to our scientific calculator. We're in degrees. So we got 4 times tangent 35 degrees And notice we got the 2.8 right there. Okay, and notice I'm in degrees, DEG, degrees there. Okay. So approximately 2.0 rounded to the nearest tenth there. Okay. All right, number 3. So now we got this approximately 2.8. Now I'm going to say cosine is adjacent over hypotenuse. So cosine 35 degrees is the adjacent side over the hypotenuse. Get the c on top, so times c, and then divide by that cosine 35. Remember that cosine 35 degrees is just a number. So c ends up being 4 divided by cosine 35 degrees. So c ends up being, let me put it in here, 4.88. Okay. Back to my lovely blue. All right, how about this one? If a is 4, b is 2, find lowercase c, capital A, capital B's. Well, let's go ahead and draw our right triangle. We got the right triangle, so angle C, so that'll be lowercase c, the hypotenuse. Call this angle A, which means the opposite side lowercase, and angle B, which means the opposite side lowercase. And they say B is 2, A is 4. Find the remaining sides. Well, I'm going to start, since I have 2 of the 3 sides, I'm going to say a squared plus b squared equals c squared. So 4 is my a. 4 squared plus 2 squared equals c squared. So c ends up being c squared equals 20. So c equals plus minus root 20 or 2 root 5 or 4.47. Okay. All right, number 2. Now I'm going to say, you know what? Let me do the b here. Let me use tangent b because I have the opposite side and I have its adjacent side. So I'm going to go tangent of b is 2 over 4, so a half. So tangent b is a half. So what I'm going to do here is I got to undo the tangent. So let's run the arc tangent. So angle B is the arc tangent of a half. Now, if I'm in radians, that would be, let's see, 0.463647609. And then if we want this in degrees. So 0.463647609 times 180 degrees over pi equals 26.6 degrees. Or we could just, here, let me clear this, make sure we're in degrees and go arctangent of 1/2, and you see the 26.565, 26.6 in other words. So that's the other way, you just do it, or just be in degrees on your scientific calculator. Okay? And it'll go straight to your degrees for you there. Thirdly, so that's our angle B. I forgot to write that in, 26.6 degrees. Well, angle A plus 26.6 degrees plus 90 degrees equals, all those add up to 180 degrees. So it looks like angle A is 63.4 degrees. Okay? So it looks like we got everything there. All right, let's, you know what, let me stop here and I'm going to do another one for applications.